Good morning, everybody, and welcome to the Reuse Company webinars. Today, we are going to talk about how you can set up your own quality metrics in RQA Quality Studio. You will be muted during the webinar, but if you have any questions or comments, you can use the chat box. But please address your comments to the Reuse Company and not to the presenter. If you have any technical issues, you can use the chat box, or you can send an email to support@reusecompany.com. The webinar will be recorded, and in a few days, we will send you the link to the recording. Today's topic is improve the quality of your requirements using advanced correctness metrics in RQA Quality Studio. My name is Cecilia Karlsson, and I will be hosting today's webinar. With me, I have Ilyas Josfi, Sales and Consulting Engineer at the Reuse Company. So this is the agenda for today. First, we will have a short presentation of the Reuse Company and the presenter. Then we will see why it's so important to focus on requirements quality. Next, we will take a look at what is requirements correctness. After that, Ilyas will show you RQA Quality Studio and the CCC approach. And we will see some advanced correctness metrics and a demonstration. And finally, we will have some time for questions. Okay, so let's start with a few words about the Reuse Company. The Reuse Company was created in 1999 as a spin-off from University in Madrid by system and software engineers. Our headquarters is in Madrid, but we also have an office in Stockholm, Sweden, and a delegation in Tokyo in Japan. Very soon, we are planning to open an office in the US. Our mission is to promote a reusable, scalable, and global solution to a smart and interoperable systems engineering environment. And we do this by offering a semantic knowledge-centric approach. The Reuse Company is also called TRC. We like to say that it's easy to remember if you think of T like in traceability, R like in reuse, and C or almost Q like in quality. You can also apply these concepts to other topics. Now, let me introduce you to the presenter. Ilyas is a sales and consulting engineer, and he got his master's degree from the University of Montreal in Canada and the IMT Atlantic School of Engineering in France. He has experience in sales and a technical background in energy and mechanical engineering. He has also been involved in a research project around the environmental impacts of end-of-life management of aircrafts. Ilyas is passionate about international projects and languages, and currently he speaks 4 languages fluently. So let's start with the presentation. Hello, Ilyas. Good morning. Ilyas? You're on mute.
Yeah, sorry about that. Good morning or good afternoon, depending on where you're listening or watching us. So my name is Ilyas Josfi. Thank you, Cecilia, for the introduction. So I will now present you the different topics that Cecilia detailed in the introduction. So first, we will define what is requirements quality, or at least try to present why we should focus on requirements quality. So probably you know about these facts. So this will be some sort of introduction into the topic, and then we will see details about the correctness characteristics in the standards, and we will look at the correctness part inside the tools, inside RQA Quality Studio. So first of all, some facts about quality. Here are some examples of defects that were introduced due to requirements quality and that had a major impact in projects. For example, in this Mars Climate Orbiter project from the NASA, the problem was conflict in measurement units between 2 software controlling the orbiter's thrusters. One was calculating the force in pounds, and the other one, another separate piece that was developed by another stakeholder into the project, was working in metric system. So in the end, the Mars Climate Orbiter crashed burned up in the atmosphere of Mars, and the loss you see was huge. So same for what happened to the French National Railway Company. So in this case, the problem was that some platforms of train stations were not taken into account because they were too old, and the new trains that were built for the network, let's say the railway network, were not fitting with these platforms. So they were adapted. So the cost to adapt them was estimated at 50 million euros, which is a huge number considering that we have to take into account the investment for the new trains. So you see $15 billion on trains, and then another 50 million, which is a significant amount here. So due to a problem of properties that were not checked. So in the end, these examples that the previous ones I showed you, there are many of them. And if we look at studies about the main factors for failure, we see that changing or unclear requirement comes second. Of course, the project schedule delays are also a big factor of failure, because it means increasing costs and also adapting changes that sometimes don't fit with the project. So you see requirements make up almost 1/3 of the project failure factors. Here there's another proof of the importance of requirements. It's that although concept and design make up less of 1/4 of the time of the project, you see that we commit after these two phases 85% of the costs of the project, because this is when we decide about the future product, and that's why the requirements in this case are very important. And the more you wait for to extract the defects from the requirements and from the product, then the more you will have to pay. So you see, that's why it's important to focus on good requirements quality to prevent the product to be developed with defects, as you can see here. So in the end, this introduction, of course, you probably are familiar with these numbers, but the idea is to set up a framework so as to define requirements quality. And here, to sum up, we say that no matter the root cause, could be software issues like the first one, or that the requirements were not considering all the properties. You see that the impact is huge, and this is what we should remember from all this. Now, if we focus on requirements correctness, let's first define what is correctness in the understanding of the international standards, and also the general definition that we give to correctness. So correctness, it might be defined generally as getting it right, which is probably the most basic definition that we could have. Then if we look at international standards, we see that one of the characteristics that is quoted for well-formed requirement is the correctness of the requirements, along with an ambiguity, or the fact that we can rank the requirements, the verifiability, traceability, and other concepts are also quoted in other standards like 29148 of ISO, and also domain-specific standards, and the well-known INCOSE guide for writing requirements, in which there is a distinct definition of characteristics, one for individual requirements and one for sets of requirements, so a specification. And you will see the importance of this difference here, made between these two cases to define the correctness in RQA Quality Studio. So this is an overview of what is correctness. It's one of the aspects. And if you look at our approach in RQA Quality Studio, first of all, if I introduce RQA Quality Studio for those who are not familiar, it's one of the tools of the Systems Engineering Suite by the RIS company, along with other tools like Knowledge Manager to manage the knowledge ontology, the vocabulary, all the patterns, all the concepts used to improve the quality of the requirements and to ensure the consistency of vocabulary between different project phases. You have traceability to manage traces between the different work products of the project. Authoring tools to help the writers follow well-formed patterns and agreed quality practices, so best practices for requirements quality. And you have the main tool here that we'll talk about today, which is RQA Quality Studio, in which you can define your own quality rules, metrics, as we call them. We'll see the definition of this later, and in which you can also monitor the quality by creating reports to help the users improve the overall quality of the specification. So in this tool that I will show you in the demo, you see that the CCC approach is our main tool, let's say our main feature to assess the quality of the requirements. So it's based on the three-dimensional approach, in which correctness is one of them. And in this case, correctness is not just one characteristic of individual requirements. Correctness in our tools address all the characteristics to check requirements individually. So, for example, the fact that we can verify a requirement, so avoiding structures like 100% or always, will be correctness as well. Although it's a different characteristic in the guides, so in the guides like the INCOSE guide for writing requirements or the standards, they will all be included inside the correctness dimension. So defined precise words, atomicity, attributes, relationships between concepts, or the requirement syntax based on patterns will all be considered inside the correctness dimension. So to give you a number here, in the default configuration of the database, there are 35 enabled correctness metrics. So the total is higher because some metrics are alternate metrics for the same scope. But in the end, if you consider the enabled metrics, the one that will be working in the default configuration, there are 35 of them. So you see, these will address more than one characteristics in the standards. So this approach can be represented by this triangle here, in which correctness is addressing individual requirements, whereas consistency and completeness will be addressing sets of requirements. So saying that one requirement is consistent to itself is not it doesn't make sense. The same for completeness. You have to check the whole specification to say requirement number 5 is consistent with the rest of the specification. Whereas quality correctness here will be considering the individual requirements. So the syntax, the use of defined and controlled vocabulary, some structures that we should avoid, and so on. Basically, if I sum up the concept of quality metric, which is how we will measure the quality in RQA, we have the CCC approach. So we have metrics for correctness, metrics for completeness, and metrics for consistency. And one quality property or rule will be implemented into one or several metrics. So each metric will have a something to measure based on a parameter, or without any parameter if we consider the non-parameterized metrics. I will give you some examples later. And in the end, this measure will give you a result, so thanks to a function, and the function will be converted into a 3-level quality value: high, medium, or low quality. And in the end, one requirement will be assessed considering the total, let's say the total score of all the individual metrics. So here you have some examples, some screenshots about the RQA Quality Studio, how it is presented. You see the correctness, real-time quality assessment on the right side, and you see your requirement. You can also display in the tool some summary about the main metrics involved and the results, and you can see the coverage of the characteristics this way. So coming back to the types of metrics, you have four main types here: the fixed or non-parameterized metrics. So they don't need any parameter to be checked. For example, the text length will be checked the same way in any project. It's just counting the number of words. Same for passive voice detection. It's not a fact that will be changed from one project to the other. Parameterized metrics like use of a specific pattern to detect one thing we want to have in a requirement, or in the contrary, something we have to avoid. Same for the words, or some group of words that you want to avoid. Let's say we have checklist. In this way, we answer a list of questions, and based on the answers, we end up with a result which has the three levels that I presented earlier, so low, medium, or high. And you have custom code metrics based on C# code that you can also develop in RQA if you want to go beyond the main types here. So considering the correctness dimension, you have different informations that you can use and different results that can be obtained from these informations. So we can have metrics based on the information coming from the requirements management system, like, for example, attributes, links, versions. So check that an attribute is correctly stated. Same for the links, same for the versions. Is the version consistent with the rest of the specification, and so on. Then we have the metrics based on the vocabulary. So is it a forbidden word? Is it a restricted word that you only should use once? Or is it a mandatory that you have to use at least once? So you have different cases that you can use that are defaultly set, and you can also add your own metrics. We have linguistic algorithms, for example, to check the readability, the misspelling. So we have a spell checker included in the tool, and you can detect passive voice, some structures that you want to avoid in terms of grammar. So all the linguistic algorithms can be also added based on the knowledge of the language, and also your own set of rules that you want to set up. We have conformance to models. Basically, this is to check the relationships between different elements, and this way you can make sure that, for example, the relationship between the system and system element is correctly stated. And metrics based on patterns. So if I speak about the patterns here are basically a sequence of restrictions that form a structure that you would like to follow for the requirements. So basically, we have patterns that are used for authoring to help authors while they write their requirements, and we have patterns to reduce false positives, for example, to introduce some exceptions, like okay, I don't want passive voice, but I want to allow passive voice in the condition sentence, not in the main sentence. So what should I do? I should describe what is the condition, so when it starts and when it ends. Basically here it starts with this condition word, like when, if, as soon as, and so on, and would end when we meet the shall word. So we can say this is condition and this is main sentence. If you have something like passive voice before, it will be okay. If you have something after, it will be not okay. We will see later how we implement that and how it is reflected in the tool. So basically, here I have a screenshot of what I'm just presenting, and we'll show you in the tool, in the demo as well. So here, one metric here is considering the passive voice out of condition. So if I have two passive voices here, one is detected, one is considered as passive voice out of the condition. So I have 2 passive voices, but only 1 is detected. So you can filter like this the use of the metric. So we detect this block here and we say, okay, this is not to be considered. Once we get out of this pattern, then we start calculating the metric and counting the number of passive voices. I get 1. I don't want any passive voice in the main sentence, so I return a low quality. And since I introduced the 2 other dimensions, let me tell you that we have some webinars already scheduled for the other dimensions of the CCC approach. So if you would like to learn more about completeness, please register to our webinar on September 28th and 30th. Cecilia will give you more information about this webinar at the end of the presentation. And we will have another webinar about consistency in October 13th and 14th. Now let's give you some aspects about the correctness, the advanced correctness features in RQA. So basically I will present you some of the features that you probably don't use when you first get into the tool, but these features might be useful if you want to higher the level of the quality assessment. So here we can define the scope of the object. So usually when we start analyzing a document and we start using the tool and we start testing it, we write some requirements, some examples, and we start testing the tool. But the real documents will have lots of information. Some of them will be, some of the elements will be requirements, and some other will be descriptions or headings or titles of any sort that shouldn't be tested as requirements. So we have to use a filter to decide what is a requirement and what is an information, the additional information. So we can use filters based on Boolean expressions, based on views, if we use IBM doors, or based on attributes, which is the example I have here. We only allow elements that are not headings, for example. The result will be this one. If you check the main view of RQA, the quality view, you see that some of the elements are identified in gray, which are what we call the non-objects, and these are with the type heading, which don't have any description, so that's why they would always return a low quality, and we don't want that to be included in the result, in the final result of the assessment. So you can then hide the non-objects, as we'll see in the demo, and just focus on the real requirement objects. Then another feature that is very important and then that often brings a little bit of confusion when you don't actually master it is the difference between computation and filtering. So we have 2 tabs here in the metric configuration that are very important. The first one is the information of the metric. It's also very important to identify the metric, but it doesn't have any anything advanced. Let's say it's just the name and the description of the metric, but then you have these 2 tabs in which you have to decide if you want to use computation or the filtering. So what is the difference? Computation, I will show you later, is a little bit more advanced than filtering. Filtering is just saying the metric will not be analyzed once I get the filter or when I don't get the filter. So the filter can be based on attributes or based on patterns. In this example, I'm using an attribute filter. So if my type is not safety, I will analyze the requirement. If my type is safety, the metric would not be enabled. It would just tell you that it matches the filter, so I'm not assessing. I'm not saying is high quality because I didn't see the mistake because I don't want to. It's just not assessed. And you see the color code is different than the computation when you don't check the metric. So basically, if you have a safety requirement like this one, it is not matching the filter. So I'm saying here, if I have a safety requirement, don't check. So this is the case here. This is a safety requirement, and we have the negative expression. The metric here is checking negative expressions, and if I say not, I can say it 1 time or 5 times. The metric will not check because we already match the filter of the attribute. So here it's a gray color code, and the sentence will be, the description will be, the quality has not been assessed. Here, as you will see in the demo as well. The computation one is different because in this case we analyze the metric. The metric is enabled in any case, but we avoid some counting based on the information that we set in the window. So for example, checking the negative expressions outside the conditions. So here what happens is that I have a condition pattern, as I said, to define when the condition starts and when it ends, and you have the negative expressions cluster that includes here all the informations like related to negative words like no, always, these kind of words. Never, sorry, no, never, and nobody, no one. So all these negative words. So here in the computation, you see the filter, and you see the negative filter here. So we count when we match or don't match the filter. So here we count when we don't match condition patterns. So we count when we are in the main sentence. So if you see this example here, we have when the radio is not connected to the external power source condition, change in the battery shall not, so then we end the condition, not result in the loss of data stored in the radio and not saved before. We have 3 nots here, but the metric result is 2. So if you remember in the filtering, we didn't check the metric. It's just saying I don't want to check it because I have an attribute, or I set a pattern that makes me avoid the metric. In this case, I check the metric, but I just don't count when it's inside the condition. So you see the result is different from the real count, let's say, the requirement total. But in the end, I have 2 negative expressions, so I'm still in a low quality requirement. If I remove these 2 negations, I keep this one, it will be a high quality, of course. So you see the difference. In the filtering, we don't check. The metric is not checked. In the computation, if we match the filter, it's checking or not checking based on the negative check here. So you have this feature to manage exceptions in the metrics. So now let's go to some advanced parameterized metrics that we can set up in the tool. We can set up metrics based on the system conceptual models. For those who are familiar with the KM, the Knowledge Manager tool, the system conceptual models is the second layer of our knowledge ontology, in which we define relationships between the vocabulary elements. So, for example, a measure relationship is relating the properties with the measurement units. So basically here what we do is make sure that the property is linked to the correct unit. So this is the intent of this metric, which is called detect inadequate unit for a characteristic. Or we can also control the values used for a given signal in a project. So the approach is the same. We have a relationship defined in the knowledge ontology. We use it for the computation of the metric. We say this is the relationship we want to check into. We set up the number of maximum relationships allowed. So if you only allow direct relationships, we just set 1. In this case, it doesn't have any impact because I only have 2 levels. One level is the property, and the other one is the character, the measurement unit. But in the case of, for example, a PVS, system structure, we will have several levels. And if we set maximum relationships to 1, we only allow relationships from level n to n plus 1. Whereas if I set 0 here, I allow any level, I allow jumps between levels. For example, if I have a train that has an air conditioning system that has some fans and compressors and so on, I could say the train has an air conditioning system, but I could not say the train has a compressor because it's jumping levels. And if I set 1 here, it's only direct relationship. And of course, we also have, as any computation tab, we also have the matching pattern part here on the bottom part of the window, which allows you to count only when we match a pattern. So what we saw just before. Then we have the pattern matching metrics. For example, in the implementation of the out-of-the-box database metrics, the passive voice is detector is based on the pattern. Here we have basically set the parameter. So when we match this parameter, we start counting the number of passive voices, except, because I have a negative filter here, except when I detect a condition. So here, this is the avoid the use of passive voice out of the condition block. We have the same function for pattern groups. So instead of having just one parameter here, we have a pattern group which features several patterns. So for example, anti-patterns to avoid inadequate grammar structures. For example, there shall be, there has to be, which is not stating the subject, or shall be designed to, or shall be capable of, all these kind of structures. And here there is no exception case. It's going to be checked anywhere in the sentence. Another metric that can be interesting is the subterms metric. So in this case, we also use the SCM view, the system conceptual model, the second layer of the ontology in KM. For those who are using KM, you know what I'm talking about, at least. You have here a structure, an example, and the idea is to control at which level we are writing the document. So if we are writing a requirement specification about the train, we only want the train shell and not the AC system shell, because it's below, and it probably needs a separated specification just for the requirements of the AC system. So to control the levels, we can use this subterms metric. So here you set the relationship you would like to look into, the term that will be the first level. You will start checking the subterms here, capability. And if you exclude the head term, it means this one will be considered okay. So if I said train here, train will be fine. But when I go to the bottom, all the terms below will be considered low quality. And we can set a parameter to check only when, so it's positive here, it's not negative. So it's only when I have this structure system. So a word that belongs to the cluster system. Cluster is also a feature of KM. Let's say it's like a semantic category that defines all the words that are considered systems in the database. So a system shell. So if train is a system, then this will work and the metric will give you this result. And if you say AC system, because the AC system is below, then it's going to tell you this is not the right level. And the last feature that I can talk to you about is the custom code metric. So the custom code metric, for example, to ensure that tolerance values are within an accepted range. This is custom code metric because it has to capture the value of the absolute value of the property, like for example, I will show you an example just after, and the tolerance value, and then compare this tolerance value, so calculating it, and compare it to the quality function. So that's why it's a custom code metric, because it involves more than one input. Basically, when you have more than one input, the solution can be addressed thanks to custom code metrics. And here we have a pattern. It's also the computation part here, although it's not presented the same way, because here it's like one window that has all the informations in one let's say in one view. You see that this part is the it's like the computation filter. So here, if we have a unit with a that requires tolerance, then we will be looking at this metric. Basically, one example is this one. If we say the voltage of the system shall be 230 volts plus minus 30%, then what we can do is say, okay, this is too high, so it's tolerance higher than expected, and the value here is 0.3, of course. And you see that the quality function is not accepted, in this case, more than 26%. So if I put 3% here or 2%, it will be too low. And of course, when you are in the accepted range here, you will get a high quality for this requirement, because the only mistake here is the tolerance value. So once you adapt it to the accepted range, it will go to high quality. So now I will start the demo. So I have 4 quick clips to describe some use cases around the advanced correctness metrics that will address most of the topics I presented in the presentation, but in with the process on how we set up in RQA. And then if you have questions, of course, you can write down, as my colleague Cecilia told you at the beginning, you can write down your questions to the host, and we will answer them during the Q&A session. So let's start with the first use case here. This one is considering the filtering of requirements. So the first feature that I presented you when I introduced the advanced correctness features of RQA. So the first step is to create a relationship here, a connection, sorry, between RQA and your requirements specification. This, in this case, in Excel. You see the column mapping that is required to start connecting. So basically, it's telling the tool in which column we can find these elements here. So mainly information is about to identify the requirements, an ID and the description, and also some optional features like the headings. And we also need the author and creation and modification dates to be able to write down the new dates once we calculate the quality, which are these columns here. And we can also add optional columns like the type that we will need to filter, as we will see later in the RQA session. So once we make sure we have the right elements, the right parameters for the mapping, we can use a specific ontology. If we don't use this window here, if you don't check this use a specific ontology, the basic configuration that will be used, the basic database, will be the active one in the server. So just for recall, if you want to fix the connection to a specific database among the available ones, you should select one specific ontology here. Otherwise, people administrating the server, if they change the active database, this would result in changing your database for the connection. So you remember when you edit the connection, or when you create it, to specify the ontology if you want the same for the project. So then we select the worksheet we want to work with. the first message when you first connect this requirement specification to the database is that it's not featuring any template. So we have to select one to start analyzing the quality, or we can say no and do it later in the tool. So in this case, I will select one template. So it's applying the template to the document. So as you will see here, we can first have a look at the view. Can go to the workbook configuration. You see that the baseline has been applied, as you can see in the document. Yeah, the baseline has been applied to this worksheet, and what we can do is check the properties of the connection. So this is the window I showed you in the presentation to filter and manage the scope of the quality assessment. Here, it's very important to make sure you don't consider the titles in the requirements specification here to be assessed. Otherwise, the result might be lower than expected because titles introduced in the second paragraph. So if we have a metric that only allow one paragraph, then you will have this metric giving you a low quality result for all the requirements. And also the fact that some titles are not don't have any verbs. So most of them don't have any verbs, which will result in another low quality assessment. So titles are not welcome in the requirement quality assessment. If you want to have titles because you're using titles as a preliminary requirement sentence, then you could use this, but usually we don't include titles in the assessment. So then once you make sure you uncheck this this box, you can use custom identifiers to be able to check the type inside the quality view. So if we add this here, you will see that in the quality control, we have access to the type defined in the Excel sheet. You can group, as you can see here, by type to be able to see at one glance the different requirements types you have in your document. And the next thing we can see is how we can set a filter. For example, if we don't want to analyze regulatory compliance because we don't have the go from the project manager to check these ones, we can filter, and you see they are in gray, all the regulatory compliance requirements, and you can check hide non-requirements to remove them from the view. And then you can launch a first quality assessment. As you already know, for the users of RQA, you get the quality results. You can rank here, filter by quality level, and you can have a look at the view of the quality. Have a look at the summary of the metrics that are mainly failing, passive voice combinators in this case, and also create reports based on this first assessment. So this was for the filtering of the objects. So once you know what elements you will be using, you see here that we keep going with this filtering configuration. Then let's have a look at the computation feature and see how we can set it up and the impact that it has. So I have to, in this case, I didn't have the ID in the window, so I can make it here display in the main view to rank the requirements by ID and identify them better. So here, in this example, you see that we have a condition when the configuration mode input parameters are validated. This is a high quality because my metric, my default metric for passive voice is not considering conditions. It's passive voice outside the condition, out of the condition blocks. So what happens if I go to the configuration of the metrics? So these are the correctness metrics. In this case, I disable some of them, so I only have 32, but the default number is 35, as I told you in the presentation. You see that we have several characteristics: abstraction, accuracy, we have others. And basically, we can start checking the metrics. So this is the metric that is enabled. the one based on passive voice, you see that there's a computation pattern here to manage the exceptions of the conditions, and it's a negative filter, so we want to check only when we don't match this pattern. Whereas if I apply the other passive voice alternate metric here, you see, which is not having any filter, it's going to check in any part of the sentence. So the result is that if I go to the same requirement I opened before, this time the passive voice will be checked because I have the passive voice and I don't make the difference between conditions and main sentences. So basically, you see that computation filters don't disable or don't skip the metric. They just avoid counting when necessary. Another example of how we can set up new exceptions in this case is, for example, the combinators metrics, so the detection of and or words. So here I'm saying ranges shall be between 28 and 30 degrees centigrade. So here, and is not a harmful word. I need it because I'm saying between and. So I need an exception for this metric. So OK is checking outside the condition block. I'm outside the condition block, so I'm checking this metric, and I have this issue. So if we have a look at this metric, we know that it's going to check outside conditions. So I have to add an exception. So in the knowledge manager tool, which is the tool to administrate the ontology, the knowledge base, I'm going to add a between and pattern. So to create this pattern, we basically type the structure. So usually the symbol we use, this is a symbol we use for the wildcard. So the fact that we expect any word before having the next one. So if we say between one number and, it's okay. If I say between the system and the system element, it's also going to work. So the idea is detecting a sequence that has between something and. So here I just want the word and, so I can change the restriction. So if for the people familiar with KM, this would look more familiar. I can give a name to the pattern, the same I used for the sentence to be created. And I will add this pattern to one of the pattern groups that we use for the exceptions. So the pattern group is called exception for combinators. So here I will add this pattern to this group. So here, if I reload the ontology, which is the feature we have for to take into account the new changes, so of the ontology, which means here the new pattern, I'm going to have a high quality in this case. So the exception has been taken into account, and I have in this first case, I have a high quality. Another example of exceptions is for another metric here to say numbers are not followed by units. Of course, 10 what? But if I say between 10 and 12 centigrades, some people might say, okay, it's between one and one value and the other, and we have the unit after. So usually we understand that 10 will be also centigrades. So some people don't want to repeat, so we can allow this exception. So what we can do is use exactly the same pattern. So if we look at the metric 140 here, we see that the exception pattern, it's negative here, is called valid numerical expressions. So all the structures, so all the patterns that are matched, that are valid for the use of numbers without measurement units or without any term, without any quantifier, will be inside this pattern group. So here we don't have the between and pattern that we just created. So if we add it here to this group, and we save the database and we reload the ontology again to take into account the new change, then we can open this requirement, and we can see that in this case, if I don't have the unit here, it's not going to be harmful for the overall quality. So the exception is taken into account, and it is a high quality requirement. Then we have another feature here that we can have so here to consider the difference between computation and filtering. So I showed you in the slides how it is working, but let's see in the tool how it is processed. So let's consider negative expressions outside the condition blocks. So this is the metric we were going to use for this use case. Here we have a computation based on an exception pattern. So negative is being checked, and we don't check when we match one pattern from the group exceptions for negative expressions. So exceptions like conditions, like maybe some structures like shall not exceed. If I say shall not exceed, I'm setting a maximum, so that's not a harmful structure, even though I used a negative expression. And we can also set attributes, so the filtering part. So we will see the difference here. If I say that safety requirements that usually have not, for example, the passengers shall not open the aircraft doors during aircraft and takeoff and landing, and during the flight or whatever. We often have the negative word inside, but this is not harmful. This is a safety requirement, so it's always setting the conditions to avoid risks. So avoiding is negative, so we don't want negative expressions to be checked in this case. So let's check if I go to a safety requirement, like this one, requirement 61. Here, there's a negative expression, shall not involve, but the only mistake here is the pronoun. So the metric is not checked. We can confirm because we have the gray color here. So the quality of the requirement is not assessed because this requirement doesn't match the metric filtering conditions. So here we just skip the metric. We don't say one, but not in the condition, or and so on. We just don't look into it, into the requirement once we match the filter. If we go to another requirement like physical design, which is not safety, the metric will be checked. And if I add a condition, when it's not required, I have not here, but the number, as you will see, will be calculated as 1. So it says 2 first, you can see, then it processes the pattern and it says 1. The final result is 1. I have 2, but final result is 1 because this one is inside the condition. So it's the exception in the computation tab, so it's not considered. And finally, the last case that I wanted to show is the creation of a metric. The example of advanced correctness metric is the one based on relationships. So relationships are one aspect of the system knowledge base, SKB here, and we will create a preset metric, so based on relationships not NCM compliant. So here we will check that the relationship is not existing in the knowledge base. So we give a name to the metric, like avoid invalid relationships in the system structure, a description, and then we select the relationship. So if it's of type PBS, so let's have a look at the PBS relationship here. So this is a PBS relationship I'm going to use, basically to check that my system and system elements are related to each other. So once we select the relationship, we can set that we don't only want direct relationships, like we don't allow jumps, as I said earlier, and we can select a pattern that I will use to allow the counting. So I'm only going to count in when we describe the structure. So once we set up the metric, we can create the new requirements here. So remember that I'm connecting to this Excel sheet. So once I bring the changes to the Excel sheet by creating these new requirements, so the temperature warrior shall have one control system and the time controller shall have one power source. I can then refresh the window in RQA, as you can see, refresh, and you see that the two requirements are being brought into the view. So the connection is kept between the Excel sheet and RQA. So any change brought to the Excel sheet can be refreshed into RQA. So this relationship is correct. So I'm having the relationship detected. And the other one, you will see time controller shall have one power source is not right, because you see the metric that I set up is alerting that the relationship is not correct. And if we look into the PBS, you will see that, of course, time controller doesn't have any relationship to power source. See, these are in two different branches, so there's no way time controller could have a power source in this system structure here. So the metric is going to tell you that it's not matching. So now let's move to the questions. Cecilia, please.
Thank you, Elias, for your presentation. If you have any questions for Elias, you can write them down in the chat box, and you can address them to the reuse company or to everyone. Meanwhile, I will tell you about our next webinar. It's called Completeness, Tips and Tricks to Address the Most Challenging Topic Towards High Quality Specification. Requirements completeness is the factor that impacts the most when verifying requirements quality. So this is really an interesting topic. The dates for this webinar are the 28th and the 30th of September. And you can follow the link for more information and registration. As Elias mentioned, we are also planning a webinar about consistency in October, and I will send you more information about that later. So let's see if we have any questions. You showed how to filter requirements with one criterion, but is it possible to have multiple criteria?
Yeah, thank you, Cecilia, for the question. So I will show you in the RQA session how we can filter using more than one element. So of course we have simple filters. So we want or don't want the attribute. So I'm opening an RQA session here, which basically is the connection I set up in the demo, and I will show you how we can create complex filters, like having more than one condition to filter the object. So of course we have to give the users the capacity to have the right filtering to consider the right scope for the quality assessment. So I'm loading the database and I'm loading the document. So here, as I showed you in the first video, I have to choose the worksheet. As you can see, the small icon here has a green arrow, so it means that I already selected the metrics. So of course, it's not going to ask me what baseline I want to use. You see the assessment, the main view of RQA, and we see some filters, regulatory compliance. But let's consider I want to also avoid the competition requirements here. So I can go to workbook configuration as I showed, double click on this line or right click in properties, it's the same. And here you see that I have a filter that avoids regulatory compliance requirement types. So what I can do is not only can I work with operators and with booleans, integers, and dates, if you want to filter by date, for example, here, but we can also use regular expressions. So let's say, as I told you before, I want to avoid regulatory compliance and competition. So I can set up my regular expression, and you will see that not only can I avoid the regulatory compliance because I kept it in the condition here, but I will also filter the competition here. Here in this case, I'm only considering regulatory compliance and competition. Yeah. So here, if I say, so let's say it's an OR, it's an OR filter here. For those who are not familiar with the regular expressions, it's regulatory compliance or competition. So here I'm saying only these two types. I could say the same for functional, architectural, and so on. But the idea is I'm only keeping the ones I stated in the condition. So it's a way to better consider the scope for your specification. So as I said, you can filter by type here. You see that competition is right here, regulatory compliance is right here, and the rest is all gray. And you can hide the non-requirements, which keeps only the two groups necessary for your scope. And then, of course, all the results should consider the requirement that you filtered. So basically, if I go to quality control and to the view or the metrics here, it should produce here a new assessment only with the filtered requirements. So it refreshes, let's say, the statistics based on the filters. So any other questions?
Yes. Are all the presented examples available in V18 or only in V21, especially C code?
Yeah, all these features that I showed you, as I can show you here using the file button here, you can see the version of the tool. You see that it's version 18.5. So all the features I showed you in the presentation are available in V18. Regarding the custom code metrics, if you want to create, in our case, we're focusing on correctness. If we want to create a correctness custom code metric, you can select add new metric here and custom code. And you can see here the computation window I was presenting you in the presentation. So yeah, the screenshot I showed you has been slightly modified in this 18.5 version, but it was AV18 as well. It has been separated the same way we have in the other metrics. So it's easier to recognize. You have always the same buttons. You have the information. Computation here is considering different elements, different outputs returned by the custom code metric. And you can either use files to define the objects or use the code editor. So once you enter the code here, you can start. So metric evaluation, you see that it's the score basically, and you can then use the C# code to have a look at to take different values and do the calculation. I can show you one of the custom code metrics that we have implemented for the tolerance. Is the one that I showed you in the presentation. You see here, this is computed. You see this, the check means the code is okay, and you can see all the code, piece of code here. So this is out of the box. This code is available in the default configuration. So if you want to slightly change the way it is calculating, or maybe have another method for the tolerance, you can also modify the code. But of course, better if you have knowledge of C#, of course. Any other questions?
Yes, the out-of-box INCOSE library can be imported to KM for use in RQA older version 15. It's actually 15.1. So the question is, can you use this with RQA without KM?
So if I understand the question, you have libraries. So in any case, the libraries should be imported in KM. So you need KM to import libraries. So this is the first point. Of course, the metrics are set up in RQA, but since most of the information is in the metrics are involving aspects of the ontology, like clusters, like term tags, like patterns, you need to import the knowledge into KM, and this knowledge will be imported together with the metrics. So let's say I save a library of this here. The library would not only have the vocabulary, patterns, and so on, it will also store the metric baselines here. So in order to import the full library, you have to use KM. So I can open a KM session just to show you the process. So this is the answering the first question. You need KM to import the libraries. And the second question is about the versions. So considering that so these are databases that have a number of tables inside. The number of tables increased from one version to the other. So it may be harmful for the compatibility to have version 18 libraries imported into version 15 databases, because some of the elements of the V18 will not find the relevant table in the V15. So my advice would be to migrate to V18. So install the tools and also migrate to databases. So the process to migrate databases is quite simple. We have what we call the database migration tool, which is a tool that enables you to upgrade to the upper versions. So if you have databases from V15, the tool is capable of making this database ready for V18. So I have here, for example, a database in V20 here. We have all different databases available. So the idea is to migrate to the right version. So my advice would be to migrate to V18 if you want to use all these capabilities that were developed after. And of course, some of the features like pattern matching, pattern filtering were being brought to the tool in V18. So some metrics wouldn't actually work in V15 as well. So let's say the tool is more powerful now with this V18 that I'm showing you. And regarding the libraries, here, if you go to the extensibility button, you have here the option to import libraries. So if I import, for example, an INCOSE library, like I have libraries here. If I import an INCOSE library, you will see that it will be bringing not only the vocabulary, but also all the metrics. So the process of importing library is basically bringing the elements into the native database. So, which is the difference with the external knowledge here that is connecting only to external sources, like a read-only, let's say, view that you can easily remove. And once you get all the elements and that it saves the elements inside the ontology, you see it's been imported. So if you go to the terminology, some words, so you see the little book here means it's a read-only. It's an open that open. You see type open, second element of the tooltip, and you have the description of the library. So the library has been imported successfully here. If I rank by ID, you will see that the first elements that we see are the ones that come from the library. So this is for the library import in KM. So if we save now, we have the library included. And if I go to RQA now, and I reload the ontology, we will see the new baselines that come from the library, of course. So I'm reloading as I did during the demo to include the new changes brought in KM. Closing and opening RQA will give you the same result, of course, because when we load RQA, we load the last version of the ontology. But this button is helping you to go a little bit quicker, because closing RQA means also closing the connection to the repository. So here I'm only doing one action instead of two, which is quicker. And we will see, so once we load all the features, the new elements here imported with the library. So you see the library is identified here with the code relevant to the database. And you see that this is the open library. You can import. Open means that I can open the baseline. If it were a locked, I wouldn't be able to open. And if it's read only, I could open but not add elements. Just read, and that's it. So basically, you see that the tools are connected together. So the libraries are one part of the knowledge that can be brought to the database. So it's managed in KM. And regarding the versions, of course, if you have a library in V18, in this case, it wouldn't work with the V15, because some tables, as I said, wouldn't be imported, and it would result in an error in the database in the end. So I hope that it answered the question. If you have more questions about the process of migrating to V18 and all the process here to import databases and migrate databases, you can send me an email and also ask our support team. So if necessary. So any other questions?
No, we have no further questions. So thank you, Elias, and thank you everybody for attending. If you have additional questions later or want more information about our tools, don't hesitate to contact us by email to contact@reusecompany.com. You can also find information on our website, reusecompany.com. Thank you very much and goodbye.